I am Meghan Okel.
I'm Erik de Guzman.
And we own Dicot Farm in Waldorf, Maryland. We grow certified organic vegetables on about 2 acres right now. We sell at a couple farmers markets in the area through a CSA program and through a few wholesale outlets.
So the whole property is about 24 acres, and then the area where we can actually grow crops is about 5 acres. And every year we grow in about 2 acres and cover crop the rest and then rotate. We grow about 30 different crops, and then within those we do about 90 different varieties.
But the most
total,
popular is probably like salad greens, tomatoes,
cucumbers, peppers,
sweet potatoes, lots of greens and roots this time of year, radish, turnip, kale. Pretty typical for a market garden farm, market farm.
We grow a lot of okra and sweet potatoes. Those grow really well here in southern Maryland.
They like humid and hot conditions, unlike humans, unlike me at least. Yeah. We also try to grow like unique varieties every year, like different tomatoes or cucumbers. Try different types every year and see what people like.
At Dicot Farm, we're going to look at and talk about agricultural water. Agricultural water is defined as any water that comes into contact with a fruit or vegetable that is typically eaten raw. Think apples, peaches, berries, salad greens, peppers, tomatoes, fresh herbs, cucumbers, and so much more. Water can come into contact with your crops before harvest, when you irrigate, when you apply pesticides or fertilizers, either as a foliar spray or through your irrigation lines, and if you spray water to remove dust or use water to protect crops from frost. During or after harvest, water may be used to wash or cool crops, and of course it's used to clean equipment and wash hands. You can assess the risks of your agricultural water by considering the source and the quality. Municipal water is generally the lowest risk because it is treated and monitored constantly. Well water is generally higher quality, especially if the well is deep enough and in good condition. And well water quality tends to be much more consistent. But the quality of surface water, such as a creek or pond or river, can change daily and even hourly. Many factors, including weather, wildlife, or activity upstream from your farm, can change the condition of the surface water. Because of this, you have to be a bit more cautious about how you use it on produce. Testing for pathogens will also give you some idea of the water quality. And if water tests indicate that there may be some pathogens in your water, there are corrective and preventive measures you can take to reduce risk. So considering the relative risks of your water sources and testing the water quality, this will help you to decide the safest way to irrigate, wash, and cool your crops.
One of the criteria when we were shopping for land was the water sources on the property. We looked at some places with like a stream running through it or a pond. Some places had shallow wells or deep wells. This property has a deep well, and it's the well for the house, so it's potable water. We do also have a pond on the farm that we want to hook up a pump and filters for irrigation, but we haven't set it up yet. The well for the house is a deep well, and it's about 370 feet deep, and it's pulling water from the aquifer rather than from the groundwater. So there's like different levels of groundwater. A shallow well would pull water from about 25 to 30 feet down, so you can get more groundwater, surface water infiltration in a shallow well. The well is in front of the house. It's on a slope, like a little hill. And the well casing and the cap are in good condition. They're not cracked or anything. And where the well is situated, there's not any like surface water that's pooling up or running past it. So it's not going to get contaminated that way. And we don't run animals near it or anything like that. So we wanted to add pond water to our irrigation mainly because the well is limited by how much it can produce. So we're getting about 4.5 gallons per minute out of the well, and that's not very much for farming. for the pond, we're planning to put a pump on it that can pull 50 gallons a minute. So we have two different kinds of irrigation that we use here on the farm. We have drip irrigation and we have micro sprinklers. The drip irrigation is what we use for most crops. The micro sprinklers we use for salad greens and some radishes, and we use it for things that are direct seeded that we had difficulty germinating, so like carrots. The main difference, or the main reason why we choose to use sprinklers on some things, is because we have sandy soil here in southern Maryland and it dries out really fast. With the drip irrigation, the way the drip works is it's this plastic tube with little emitters every so often. So on ours, we have emitters every 6 inches. No, every 8 inches. So the way our soil is, when the water drips out of the drip line, you get a circle of water about that big, or a wetted perimeter of about that big around each emitter, and then it's bone dry right outside of that. So if we have something densely planted, like carrots or salad greens, we want total coverage of the whole top of the bed to be wet. And so that's why we use sprinklers for those. When we have the pond water and the well water both running on our farm, we're going to use them for different crops and different purposes. So the well water we'll use where we need the cleanest water, like for the wash pack in the barn, and for the sprinklers, because most of the things that we sprinkle are salad greens and things that get eaten raw. And then the pond water we'll use mostly for drip irrigation. The biggest thing that the different irrigation systems affect is how we put all of the things that get sprinkled together in one field, so that we don't have to move sprinklers around too much. Okay, so this is the pumping system for our pond, which we haven't installed yet because we got a lot of rain this year, so we actually haven't needed it so far. I'll just go through the different pieces. This is the suction hose. It's a hard hose so that it doesn't collapse when the suction is on. This is the end that goes in the pond. It's just a strainer for keeping big things out of the pump system, like frogs or large pieces of debris. From there we go into the pump. This is a 1/2 horsepower pump, capable of pumping 50 gallons a minute. And then we go into the filtration. So all of the filtration in this system is just for particulates and solids. It's not for filtering out pathogens. This is a big sand filter capable of filtering out a large amount of water. Then from there we go into the disc filters. I added the disc filters just to get a finer filtration, because we'll be running a lot of drip, and the finer you can filter out particulates, the longer the life of the drip tape. I chose to go with 2 disc filters, and I'm going to run them in parallel so that we have less pressure loss. Inside these disc filters is this stack of plastic discs, and on the sides of each of these discs are little grooves, and when this gets pressed together, it makes a lot of very small holes for the water to pass through, and that's what filters out the particulates. When this gets clogged or dirty, you can take it out and just wash the plastic discs. For the sand filter, when this gets dirty, what you can do is back flush it. And this set of pipes and valves is what lets you back flush it. Basically, you just turn these valves so that water runs backwards through the sand filter, and then that water you would outlet to back to the pond or on the ground, and that cleans up the sand. That's basically it.
Okay, so we are going to do a water test of our well water, and we are doing it here in our barn, which is our wash station and where we do all the washing and packing of the vegetables. So this is our hand washing sink. We've let the water run for 5 minutes because you want to get make sure you're getting water. It hasn't been sitting in the system for too long. And you want to make sure that you wash your hands before you take the sample, because you want this to be as pathogen-free as possible. So this is our hand washing station. I did take off there is a cap that is on it, but you don't want anything to get caught up in it or any of the sediment that's in there to affect your sample. So we removed it for this purpose, but I'm gonna wash our hands. And then with clean hands, we will take the cap off of the container that came from the lab. Don't rinse out the container at all. Just take off the cap and basically fill it. And then cap it. And then it does need to be put on ice right away. So usually the lab will have a pack or a container, and you want to put it in according to the instructions. So the lab will provide instructions as well as the type of packaging you need so that you can return it on ice. And you want to follow their instructions for packing and mailing it to ensure it gets to the lab on time.
Not every farm uses sanitizer in their produce wash water. And at Dicot Farm in Waldorf, Maryland, they choose not to. Here we can see Max Feder at Dicot Farm spray washing Hakurei turnips, sometimes called a single pass spray method. He's spraying with well water. The turnips don't sit in the water and it drains away immediately. And here, Max is dipping bok choy into a tub of water to rinse off any easy to remove dirt. The water in the tub is well water and the bok choy isn't submerged for long. Educators may recommend it, and audit standards may require using a sanitizer in reused or recirculated water. But ultimately, it is up to the farmer to use their judgment and assess the risk of cross-contamination in their washing process. At Dicot, all the food contact surfaces used in washing vegetables are cleaned and sanitized daily when in use, and the well water used for washing is potable, which means that water test results show no detectable coliform or E. coli. The farmers don't make any claim that their vegetables are pre-washed, and they don't have any customers or food safety audit standards they must comply with that require they use sanitizer in their vegetable wash water.